Hello students, I am Professor Sameer Sabharwal. Welcome to my class of Organic Chemistry. This is my fourth lecture of Organic Chemistry, and I am basically discussing all named reactions of organic chemistry with mechanisms. Now today's topic is coupling reaction. In my previous lecture, I gave you information about diazotization process. How do we get benzene diazonium salt from aniline? Now benzene diazonium salt is a very special reagent with the help of which we can get number of products. Like in previous lecture we did preparation of chlorobenzene, bromobenzene, iodobenzene and cyanobenzene under the name Sandmeyer's process or Gedermann's process, that was modification of Sandmeyer's process. You can go for Bals-Scheiman reaction, preparation of fluorobenzene. You can convert benzene diazonium salt to phenol. You can go for deamination reaction to get back benzene. You can convert benzene diazonium salt to nitrobenzene. So many reactions are there. Now here I am going to discuss second aspect of diazonium salt, benzene diazonium salt, in which diazonium group is retained, that is not removed. In earlier reactions, nitrogen was coming out and there was a conversion of diazonium salt to chlorobenzene, means there was a replacement. But now in these reactions, in coupling reactions, diazonium group is retained in the product. Now the first very important reaction of benzene diazonium salt is with phenol. We must know that the most important characteristic feature of aromatic compounds is electrophilic substitution reaction. Okay, and we should know the reason behind that. Aromatic compounds, they have resonance. Because of resonance, they do not prefer addition reactions and they behave like saturated molecules like alkanes. And since generally aromatic compounds are electron rich, that is why electrophile attacks them, and due to which attack of electrophile becomes more favorable and substitution is preferred. And interestingly, if we have derivative like derivative of benzene where group attached to benzene ring is electron releasing, very important again, phenol, aniline, these two cases have a strong tendency to show electrophilic substitution because NH2 and OH groups are considered as a highly electron releasing group due to dominating plus R effect. Make these things very simple. I am saying phenol and aniline, both these groups favor electrophilic substitution reaction to a greater extent because these are strongly electron releasing groups. That is why electrophilic substitution is highly favorable in them. So coupling reaction is shown by those aromatic compounds where strong electron releasing groups are present. I mean to say these coupling reactions are very special examples of, yes, electrophilic substitution reactions. And electrophilic substitution reaction is promoted when we have electron releasing groups. So this is a strong electron releasing group It increases electron density at ortho and para position. And during these reactions, para product is the dominating product because of less hindrance at para position. The product is thermodynamically more favorable. Now you can see HCl is coming out in this reaction and you get para hydroxy. This is para hydroxy. Azo, we call this as azo group, azobenzene. This is a dye. So we get dyes by these methods. This is azo dye having orange color, para hydroxy azobenzene. Ortho product is also formed, right? Mean this electrophile, this is an electrophile, species having positive charges electrophile, is going to attack phenol. So what is its nature? Here it is behaving as nucleophile. So attack at ortho position is also observed, but that would be minor product. So very special case, you get para-hydroxyazobenzene. Remember, diazotization reactions are observed at low temperature 0 to 5 degree. Is that clear? And one again very important thing, that phenol, if you know that phenol is an acidic molecule, its pKa is 10, approximately 10. That is Ka, acidity constant, is 10 raised to power minus 10. So you see this, that if this is molecule acidic, a way to remember, for phenol, which is a slightly acidic molecule, pH is maintained at 9 to 10, means basic conditions maintained to perform this reaction. Now you can see second molecule is aniline, which is basic, slightly basic, and you can check for this a slightly acidic medium is maintained, pH 4 to 5. So this is the way to remember the product. So product is governed by acidity, right? And temperature is, you have to maintain temperature, because if temperature is above 5 degree, you won't get this product, right? So if I take aniline, I treat it with benzene diazonium chloride, pH 4 to 5, 0 to 5 degree. Please check this. Again, HCl is coming out. Electron density is observed at ortho and para position. Para is more favorable, less steric hindrance is there. So we get para amino azobenzene. This is a yellow dye. So very useful reactions. These two reactions are also used to identify or distinguish these molecules from other molecules, right? So if you want to distinguish phenol with any group, yes, you can distinguish phenol with the help of coupling reaction, a very useful reaction. Then again, I'm going to give you preparation of very special indicator. This is sodium salt of sulfonilic acid. We have NH2 group and salt of sulfonic group, SO3H. That acidic hydrogen is replaced by sodium salt because it's a soluble salt. So because this salt is soluble, so we have taken its sodium salt. So this is sodium salt of sulfonilic acid. Just like we go for a diazotization in which we convert aniline to benzene diazonium chloride, here we are converting NH2 group to diazonium group. You can check this by diazotization process. Here HCl is taken in excess and we get benzene diazonium salt of sulfonilic acid, right? Now this has become electrophile for coupling reaction, and you must know that in coupling reaction is favorable in phenol or in aniline or derivative of aniline, because these are electron releasing groups. They promote electrophilic substitution reaction. Now this is N, N dimethyl aniline, right? We have taken N, N dimethyl aniline, right? This is N comma N dimethyl aniline, 0 to 5 degree. Okay, yeah, slightly acidic condition because the molecule is basic. This HCl will come out, electrophilic substitution reaction. You get product which is a very special dye known as methyl orange, which is used in acid base titration reactions. We normally do these reactions of titrations in +1 and +2. Methyl orange is preferred when we have acid base titrations, and preferably this is done with the strong base and strong acid, or acid must be strong. You can take weak base also, but acid must be strong. So any kind of your acid, but any kind of base but with strong acid, fine. Then if I take a case of para-aminophenol, you just see this molecule, para-aminophenol. In this case of para-aminophenol, there are NH2 and OH group in the molecule, so it is governed by the pH. If I make the medium acidic, you know, if medium is acidic, then reaction with aniline is preferred. See, para position is occupied, ortho of NH2 and ortho of OH group is available. If I keep the medium slightly acidic, then coupling will occur according to NH2 group, right? I'm talking about this condition. So you get product at this position. So if you remember nomenclature, preference order, if OH and NH2 group is there, OH is taken as principal group. Sequence order में ये पहले आता है. Then product is formed according to NH2 group. We get 4 amino 3 phenyl azophenol. Azo means N double bond group is known as azo. So 4 amino 3 phenyl azophenol. And if I keep medium slightly basic, then product is formed according to OH group. Then coupling will occur at this position, right, or this position. See, you see the starting molecule, medium is slightly basic, reaction will occur according to OH group. So which position? Second position, like this. So see, group is attached here or here, it's one and the same thing. You attach it to this side or to this side. This is 4 amino 2 phenyl azophenol. Please check this molecule, a very important part. Let me give you a proper detail also, just to clarify. I'm just clarifying that methyl orange is an indicator. It is used for acid base titrations when base is strong, right? We use phenolphthalein, means phenolphthalein is used for strong acid as well as strong base, but base must be strong for phenolphthalein. Means you can go for titration of strong acid with strong base and weak acid with strong base using phenolphthalein. And for methyl orange, I'm again clarifying this. For that, acid must be strong. So if you do a titration of strong acid with strong base or strong acid with weak base, you can use methyl orange. Is that clear? But acid must be strong. If acid is weak, you cannot use methyl orange. So I just want to clarify that. इसीलिए मैंने इसको दोबारा आप तक पेश किया है. तो these are important things, additional knowledge. तो आप इसको you can remember it that methyl orange is an indicator जो acid based titration में यूज़ किया जाता है। तो ये था, दिस इज़ ऑल अबाउट कपलिंग रिएक्शंस शोन बाय डायज़ोनियम सॉल्ट। तो generally used to distinguish molecules like phenol and aniline from other molecules. Thank you very much.